Hey everyone, I'm Vaibhav, and today I'll give you a brief background on how BAML can help you ship agents a lot faster and more reliably. So at a very high level, what we just like to start off with is just the premise of how API calls work. We used to live in a world where API calls failing 5% of the time was horrific, your company shuts down. You swap one word out to LLMs and suddenly our expectations just start changing. And we just don't believe that's the way software should be built. You won't be able to build reliable systems until you can solve this problem. And in reality, the hardest problem here is fault tolerance. When you think about LLM agentic systems, everything now has to be fault tolerant. And the way that we have to solve this problem is just change the way that we build these systems. For example, in a large distributed system, you never make an assumption about a machine existing or a microservice existing. You always have different kinds of horizontal and vertical scaling built into it. We have to think about new paradigms with LLMs that allow for this system as well. Our team's background is based in this, but I won't bore you with that. I want to jump back into how we write agents. When we used to write websites, some of you may remember the day when a website looked like this. But now, websites look like this. And this is much more reactive and much easier to express complex ideas. The reason is, in the old version of websites, we had strings everywhere. State management was impossible to go and use. Dynamic components are virtually impossible to go build, like an infinitely scrollable web page. Reusable components didn't really exist. And iteration loops took minutes because your entire website had to compile from scratch, and if something broke, you wouldn't find out until some string got compiled somewhere. As a very general principle, we called it low engineering rigor. React added engineering rigor to our systems. The idea that set count automatically changing this will cause a re-render loop and re-render the right count here is just a thing we take for granted and magically works with React. And really, the syntax we use changes how we think about these problems. We don't have to think about the nitty-gritty of exactly what's going on. The syntax, use state, set count, expresses the ideas in a way that we all universally agree and is consistent. The same thing is true for prompts. If you've ever written a prompt that looks like this, with if conditions, new lines, and really just hard coding the model web requests that are coming out of it, your code will somehow and at some point turn into this. We just don't think this is good. It's the same system as website. You have strings everywhere. Context management is impossible to go build. If you change one step in a previous pipeline, who knows what it will break downstream. New models come out all the time, and swapping models is essential to success. And once again, our iteration loops take minutes. We classify this as low engineering rigor. The way we think agents have to be built is you want to be able to take the benefit of these really expressive models, but you want a system that is reliable, so you need the structure of code and software engineering. If you've ever seen any of these AI frameworks, one common problem that every single one of them have, including the native SDKs, is this famous blog post called "FU Show Me the Prompt" by Hamel Hossein. The idea that these libraries will just add magic and somehow the LM will work is nice at a first glance, but fundamentally, to make an LM really work for your use case, you need to be able to see the prompt you're sending into it. If a library goes ahead and abstracts away the prompt, you have no control, they check in a mistake, and you will pay the consequences for that. This primitive of just seeing the prompt is essential to successfully building an AI pipeline, and that's just one of the things. So why don't I just show you how we go do this over with BAML. In BAML, everything lives in your code base and every function exists in a BAML file. And every single prompt ends up looking something like this. Every prompt is a function. Functions take in parameters of any kind, including multimodality with images and audio. And then they return a data model. In this case, the data model is also expressed in code. And now I define what model I want to use, and I can use any model I want from open source to closed source. And then I write my prompt. Now, this is the beginning of how it works. This is where your developer flow really starts to differentiate from every other system. You click this button called Open Playground. And now you're able to actually see the prompt in real time with your inputs rendered right away. Where is this coming from? This is a test case described in your code. If I switch to a different test case with an image, you can see the image. Everything about the full prompt is always visible. If you change it, it changes in real time. You can write if conditions or anything else you want over here. Be careful. Okay. You can see this isn't rendering, but if I reduce the if condition, we start getting this condition popped out. The whole point of BAML is to make it very, very easy to write programmatic prompts that are expressible like English, but work with code. Now, this is one aspect of it where you can not only see the prompt, but you're able to see the tokens that are being passed into the model. And lastly, you can even see the raw web request under the hood that is being used and sent. So if I change this from OpenAI to Anthropic, you can see the web request changes. It uses max tokens, messages, but with OpenAI, we use messages role system. So it is just an easy way to debug what's going on. And lastly, we have testing and evals built in. So you can see over here, the model is spitting out a bunch of noise because I told it before answering, list why the person may be a good hire. So it's doing that, and then it's listing out all my sequences. And what BAML does is three things. It creates a prompt based on your definition over here from the parameters. It then calls the model based on the client you have configured. And lastly, it does a very important part, which is it parses the data from what the model says to the data model that you want and define. So even though the model gave us all these reasons, which can help it for techniques like chain of thought, and then we also decided not to output any quotation marks over here and thereby reduce the tokens that were being cost over here, we were still able to go and get the structured data model that we expected in our code base. And as you can see over here, this is not JSON compatible, but this element is. And we do this transformation from the raw response to the data model of your choice in real time in under 4 milliseconds. And we can do it while streaming as well if you pay attention. Slowly fills itself in. And of course, you can always see history and see how things are working. Now, at some point, you're going to want to go from your BAML code to your Python, TypeScript, Java, Go, any other code base you have. This is another place where BAML makes it very, very easy. What you're able to do is you can take any BAML function and say we made a new file called demo.py. And then in this demo.py, we're going to use this extract resume method. Here's what we do. From BAML client import B, resume equals B dot, and you can see it auto-completing. And resume takes in a string or an image. Now resume.experiences, experience will be a list of experiences. Let's jump back into my BAML code and see what happens if I change experience to a string array instead. Now in my Python code, it also becomes a string array. So your BAML code is always in sync with your TypeScript code or your Python code or your Java code or anything else you want. Eventually you may start streaming. We offer the same level of consistency during streaming as well. When you're streaming, email is optional or none. But when you're done streaming, the email becomes solidified because during streaming, the LLM may not yet have produced the email field. In conclusion, BAML allows you to express your prompts programmatically, have debugging tools that let you visualize the prompt, the raw web request, so you never have to inspect what's going on, allow you to use any kind of model of your choice, including retry policies, round robins, fallbacks to other systems, and lastly, has an amazing parser that allows you to express any kind of idea, including chain of thought, in a single prompt, while taking advantage of structured outputs with type safety in any language of your choice, whether it be Python, TypeScript, Ruby, Java, or anything else that we support. Thank you.